Question 23. In the figure, G is the circumcenter of triangle ABC. H is the orthocenter of triangle ABC. Angle BAC is 60 degrees. This angle is 60 degrees. And we also have BG, G, the circumcenter, BG produced, meets the circumscribed circle at F. That's the condition. So we can see that BGF is a straight line. Our first task is to prove AFCH is a parallelogram. AFCH is a parallelogram. Now, like I said during the lesson, it's important to know where G and H are. Now, G is the easier one because the question says BGF is a straight line. BG produced intersect the circle at F. So BGF is a straight line. G must be here. Okay? Now, so we only have to figure out H. Now, H, like I said, H, there are 3 points here. You can see there are 3 points here. Now, which one is H? Remember, H is the orthocenter, and orthocenter is the intersection of 2 or 3 altitudes. Okay? So we have, you can see that AH, AHD, and CHE, they are altitudes. And this line, BGF, is not the altitude. Okay? BG basically is not anything. It's not a special line inside the triangle. Now, some students may say, oh, isn't BGF the perpendicular bisector of AC? I say no. We know that G is the circumcenter, which lies on the intersection of 3 perpendicular bisectors. But here inside this figure, the 3 perpendicular bisectors are not joined. We don't know where they are. And also, perpendicular bisectors do not pass through any of the vertices of the triangle, which means BGF is not the perpendicular bisector. Do you know what I mean? Okay? So that means this angle is not 90 degrees. The angle at this point is not 90 degrees. A lot of students made a mistake because they think this is 90 degrees. Think about it. Think about it. It's not. It's not. Yes, you can, if you have doubt, maybe you can draw 3 perpendicular bisectors from G. You can draw. Okay? But none of the 3 perpendicular bisectors from the center to ABC, the sides, is BGF. BGF is not. Basically, we can always assume that the perpendicular bisectors of sides should not, unless it's isosceles, should not passes through any of the vertices. Right? Let me erase this. Erase this. So we know that this is altitude, and BGF is not altitude. So the intersection of 2 altitudes can only be here. So H is this point, not these 2. H should not lie on BF. Right? That's the first thing, to identify these points, since they're very close. Now let's prove. Let's move. Now I'm going to use the definition of parallelogram. Now, proving 2 pair of parallel sides. It's not that difficult, okay? Now, first, because G is the circumcenter of triangle ABC. Therefore, G is the center of the circle ABC. Circle ABC. So it's not just the circumcenter, it's the center. It's the center of this circle shown, okay? Therefore, BGF is a diameter. Okay? That's very important. And then we can continue. So, because AHD is perpendicular to BC. Perpendicular. Maybe I should say because. Because H is the orthocenter. Therefore, AHD is perpendicular to BC. Also, at the same time, this is 90 degree as well. Now, because BGF is a diameter, therefore, FC is also perpendicular to BC. Therefore, you can say AHD is parallel to FC. And here I'm using corresponding angles equal. Right? Now, similarly, I can prove the other two lines, now, which is CHE and AF. Parallel. Similarly, I can prove CHE is parallel to AF. Now, because the steps are exactly the same, so you can just write down the results like that. And therefore, we have AFCH is a parallelogram. This is by definition. You don't have to write this. If you're using any of the other tests for parallelogram, then you have to write the reference. But this one is by definition. That's part A.